Hello, in this video we are going to just see how we can analyze the characteristics of an SMA connector in CST. So SMA means subminiature version A connectors. So these are the type of connectors which are mainly used to connect the antennas to external devices, and these connectors usually will be having an impedance of 50 ohm. The main parts of these connectors are it will be having an inner conductor and an external conductor, and the inner and external conductors are separated by a dielectric. So this dielectric is mainly made up of PTFE. So in this video we are just going to see how we can analyze the characteristics of the conductor. So I'm mainly going to consider these parts to analyze the characteristics. So the main parts that we have to consider while analyzing the SMAs are the inner conductor dimensions and these dielectric dimensions. So based on the SMA that we are using from their website, you will be getting these details. So this is one of the example that I have plotted here. So this is from this website, these details. So if you want to analyze the impedance of the SMA connector, you can use this calculator from the Pasternak. So this is the cross-sectional view of the connectors, which will be having the inner conductor and the outer conductor, and this is representing the uh, dielectric in between the inner and the outer conductor. So epsilon r is the dielectric permittivity of the uh, um, dielectric that is used in between inner and outer conductors. So these are the equations that can be used to analyze the impedance, cutoff frequency, etc. So this cutoff frequency means that uh, it will be working from some minimum frequency up to this cutoff frequency based on the analysis. So for our purposes, I'm going to use the inner conductor diameter of 0.9, because here you can see that inner conductor diameter is G is 0.9 here. So I'm going to use that value 0.9, and the dielectric outer diameter is 3 mm, and the dielectric constant that I'm going to use is 2.1. This is we usually use for PTFE. So if you calculate that, here you can see that the impedance is approximately 50 ohm and it has a cutoff frequency of 33.8. So these are some random values I have chosen. These outer diameter is some random values that I have chosen to get these characteristics. So let's see how we can analyze these in CST. So these are the considered dimensions for our analysis. Inner conductor radius 0.45 mm, dielectric radius 1.5 mm, and dielectric is PTFE. So let's do the analysis. New template, and if you go to the circuits and component, you can get a TEM connector, time domain. So I'm going to use this connector for a 2.4 gigahertz frequency. So I'm selecting the frequency range from 1 to 4.8 gigahertz. So I'm going to select the electric field here at 2.4, then click next, then finish. So here I am not going to design entire thing like the external part that is coming for the SMA connectors like this. So this one I'm not going to design that. I'm just going to design these inner parts just to analyze the properties. So let's see that. So you can go to the modeling, and we have to first create the inner conductor, so that I'm going to use that inner conductor. So inner radius is 0 and outer radius is R1. R1 is 0.45 based on our design, and I'm going to give some H minimum and H maximum. So going to click OK. R1 is 0.45. H minimum I'm going to put it as minus 6 mm. H max H max H maximum I'm going to take it as 0. because my purpose is just to analyze the characteristics of this SMA connector. Next, we can draw the dielectric. So this is made up of PTFE. So here also you can, so the inner radius is because it has to come from this inner conductor to the outer layer. That is why inner radius is R1 and outer radius is R2. So based on our analysis, R2 is 1.5 and this one also you can give as H min to H maximum, and we can load from material library PTFE. So these are the characteristics of PTFE. It has a dielectric constant of 2.1. I put PTFE, then click OK. R2 is 1.5. So I have the dielectric layer. Next is we have to put on an external conductor layer also. So for that, inner radius is from this to R3, which is H min to H max. R3, I'm just going to put thin layer like 1.8. Oh, sorry, this is H min. So we have the SMA connector basic structure. So if you want to simulate that, now we have to assign the port. So just click on F, it will select the phase and click here, ports, new waveguide port, assign the waveguide port. So you have to just make sure that this arrow direction is inwards, and if you have to assign the port on the other direction, click on here and assign port, new waveguide port. Just make sure that this arrow is towards the inner direction. So we have now two ports, and just make sure that the background, so in this background we are going to put PEC, and the boundaries also are also PEC because this is just as the external is surrounded by the metal, we are just going to use the boundary as electric everywhere. No need to use the lambda by 4 air boundary in this case. So we can use the electric boundary here so that we can do the simulation very easily. Global properties, if you want to improve the simulation result, you can always increase these mesh properties. Then you can go for the simulation and start the simulation. Okay, so the simulation is complete now. If you go to the S parameter, you can see that S11 performance like this. Here you can see that it is very low value. That means that whatever is given at the port 1, it is completely transmitted to the port 2. And S21, you can see that it is very low value. That means that there is no loss, and whatever we are giving on port 1 is completely transmitted to the port 2. And if you want to see the line impedance at this point, you can go to the port information and line impedance, and here you can see that at 2.9 means whatever be the frequency, you can see that the impedance is given as around 50 ohm. So this dimension is very suitable for using for the 50 ohm impedance. So if you want to connect an antenna to the external devices, you can use these connector having the dimension of inner conductor 0.45, outer conductor 1.8 mm. So if you have that SMA connector, you can use that for connecting antenna, uh, that is for the 50 ohm usage. And in 2D 3D result, you can also see the electric field inside these things. So this is mainly useful to analyze how the field is propagating from the inner to outer conductor. So if you just animate, you can see that how the propagation is happening. So you can see how the propagation is happening. So it will be alternating like this. Okay. So if you get a SMA connector having the parameters like this, which is can be useful for antenna applications. So this is how we are doing the characteristics of SMA connector. I hope the video is helpful. Thank you.